Hi, I'm Koming Leung from Group2. In this presentation, we are introducing a secure PaaS service designed for financial applications using AWS. This picture shows an overview on how our proposed architecture looks like. Our team will give you a brief explanation why these services are needed and guide you through how they should be implemented. First, let's start with availability zones and VPCs, as well as private and public subnets. VPC is a setup to control how resources are connected to the exposed to the internet. In this VPC, we have subnets attached. Internal use resources should be put into the private subnet, while those for customer use should be put into the public subnet. When it comes to the implementation, as you can see here, we name our VPC as VPC Financial. The IPv4 address assigned is 10.0.0.0/16. This should give enough address for future use. When we go into the subnets, as you can see here, there are 4 subnets created. 2 are private and 2 are public. They are all under VPC Financial and resided in 2 availability zones in pairs. These are their IPv4 addresses assigned. There are other services applied in these components. We set up an internet gateway at the VPC level. Then we have route tables to control network traffic between subnets. We also have a net gateway in front of the private subnets. Going back to the implementation, you can see here an internet gateway is set up. It is attached to our financial VPC. Route tables are associated to the corresponding subnets, as you can see here. For example, this RTPRI01, it is associated to private subnet 01. The route is targeting only to internal traffic and to the net gateway. For the route table for public subnets, take RTPUB01 as an example. It is associated to public subnets. The route here should be 1 for internal traffic and 1 to the internet gateway. The net gateway setup can be seen over here. It is associated to the private subnets, and the connectivity type is private. Apart from these, some other services are also implemented to strengthen the system security. First, we have a network ACL. It controls the message flow in and out the subnets. Besides, we have security groups to provide security on instance level. Between the availability zones, we have elastic load balancing and auto-scaling groups to efficiently distribute traffic and avoid attacks such as DDoS. So when it comes to the implementation, for an ACL, for example, in this ACL for private subnets, only these inbound rules should be applied. For outbound rules, as they can go to the web, so HTTP, HTTPS should be allowed. For inbound rules in an ACL for public subnets, HTTP, HTTPS protocols should be allowed as they accept traffic from the web. For outbound, these rules such as SSH, MySQL should be allowed. Also, please be aware that rules are checked in the order of rule number, so the most important ones should be put first. For security groups, it is a similar concept as an ACL. For example, security groups for instances in private subnets, only these 2 should be allowed as inbound, while these should be allowed for outbound. For the public one, these should be allowed as inbound, while these should be allowed for outbound. For elastic load balancing, we have 2 types, application and network load balancer. For the application one, we have set up these, for example, linking to the VPC, availability zones and subnets. For the network load balancer, the settings are below. For auto-scaling, it is linked to our subnets in the VPC and also the ELB as well, as you can see here. Several services are put in the subnets. We have EC2 as a computing service, S3 RDS and QLDB as database for different purposes. Take one EC2 in private subnet as an example. As you can see here, it is put under our VPC and also the corresponding subnet. It is a Linux platform. It is linked to the security group with these rules applied. We have also a key pair for access. For S3, the access point is from our VPC. All public access is blocked, and also we enabled bucket versioning. For RDS, it is linked to our VPC. It is using a DBR5 large DB class. Also, IMDB authentication and encryption is enabled. For QLDB, it is a standard permission mode, and encryption is enabled as well. So that's all from my part about ACs, VPCs, and subnets. Let me pass to Yelwin to talk about the backup and disaster recovery components.
Hi, my name is Al, and my student ID is 124648555. Today, I'm going to present and demonstrate the backup and disaster recovery option for assessment number 3, secure financial application in PaaS environment in AWS platforms. So basically, I have 3 points to demonstrate. Number 1 is Amazon Glacier service. Number 2 is EC2 auto scaling, and number 3 is Amazon EBS for backup and disaster recovery purpose. In order to create apply the Amazon Glacier, this is a local storage and backup solution for data preservation and disaster recovery. To be able to set up this service, basically we need to use the AWS console. So I'm going to log into AWS console. As you can see here, I'm already in S3 service. Prior to configure the Amazon Glacier, we need to create the packets. So I already created the packet finance 01010101 S3 finance. To be able to create the new packets, we just click on create packet. The most important thing is we need to use a lowercase naming standard. Since that uppercase is not allowed. So once we have the packets, we are ready to configure the Glacier. To be able to configure the Glacier, we just click on Services, S3 Glacier, and then if we don't have any archive vault, then we can create the vault by clicking Create Vault and follow the default setting. At the moment, I already created the archive with the default setting. So this once the volume is ready, so we can basically download all the archive back into S3. So this is the Amazon Glacier. So I'm going to talk about EC2 auto scaling. So what is EC2 auto scaling? So this is the auto scaling group you use in AWS EC2, and the scaling elastic load balancing. If one zone's fail, availability zone is fail, it can initiate a backup instance in the different availability zone. So to be able to configure, we need to log into EC2 via Amazon console management console. I already logged into Amazon Management Console under EC2 dashboard. For the auto scaling, we have an option called auto scaling, as you can see here. So we click on auto scaling. So it's going to take you to auto scaling option. If we don't have any auto scaling group, so we can just click on create auto scaling. So for the moment, I already created auto scaling group called AS Financials. So we are actually using the temporary financials image. As you can see here, we have all these options. So we are using all the default options here. So we go basically check this activity here. So as you can see, we have the successful activity. We can also monitor all the activity here. At the moment, we actually tick the enable options to avoid any additional charges. Then we can click on CloudWatch Monitor and then check all the metrics. It's here. In order to create Amazon EBS snapshots, we need to create the volumes first. To be able to create the volumes, we got to log into EC2 dashboard, as you can see here. So we click on Elastic Blocks Store Volumes. Click on here. So if we want to create a new volume, we can just click on Create Volumes, and then use the default setting. The most important thing is we have to make sure we use encrypted encrypted volumes. So as you can see here, we have all these volumes, and if necessary, we can just select the particular volumes, and we can click on Actions, and then we can create a modified volume, so detach volume, and also we can set up the manage or to enable input output here, as you can see here. Yeah, thank you.
Hello everyone, I'd like to make a quick presentation about the AWS authentication control and monitoring implementation in our project. The first part is the CloudTrail, the second will be the CloudFront, and the last part will be the Cognito. The CloudTrail is one of the most important monitoring parts in the AWS. It will help to managing the advanced operations and the risk editing, and will clearly shows the AWS account activities, and the CloudTrail is easily to monitoring and on the currently performance without reading the log. We can see on the picture on the right, it will clearly shows the event name and the event time in the event history tables, and we don't need to find the details in the log files. Let me do a quick demonstration. In the CloudTrail, I have implemented normal trails for the project and the management trails for the project. In the event history, we can see the recent event in this table. And if we want to search a specific event name, we can just type over here, like the console logins, to check the login details in the last 24 hours. And we can also click in here, and we can see the very detailed information about this user, their source IP address and their regions which when they are logged in. The next part is about CloudWatch. CloudWatch is about monitoring the cloud resources such as CPU usage and the load balancing on the memory capacity. And I can also use the matrix to calculate statistics and present the data graphically into our CloudWatch console. And in our dashboard, we have created all our projects. We have implemented more than 8 matrix over here, which is very important, like the number of objects we have using and the incoming bits we are currently receiving. And if there is any error, it's in our log files. And I have also created alarm details, like there will be 12 alarms currently, they are all okay. And these alarms are about the database, the volume, and the frameable memory of the database, and the CPU usage. In the last part, I will discuss the Cognito. Cognito is using its identity pool and the user pool to control the user access to our application. And Cognito can combine with the CloudTrail and CloudWatch to monitoring our users' performance. And let me also do a very quick demonstration. This is our user pools for this project. I've set different users currently are our team members, and the attributes like the email address and the policy for the password. And the most important is the app client settings. Like we have to use our Cognito user pool. And we will set the URLs for the users successfully logging in our website. It will redirect it to the Amazon main website. Currently, we are designed like this. And we also use authentication to allow to make more secure with the emails and open IDs in the URL. And I will do a quick demonstration when a user try to log in. Let me create a user called demo and a temporary password. You can see there's a new user called demos over here, and we can log in. This is our login page, and we can type demo and then try to log in. When the user tries to log in at the first time, it requires them to change the password, and we'll change the password. And require their email address, like email address. And the user can log into our the website. And these are the monitoring and authentication controls I have implemented this in this project.
Hi, I'm Zhao Huanjie in Group 2. I'm responsible for the security components of the design. In this part, we have 6 components, so let's start from the first one. CloudFront. This application is utilized to transmit data, video application, and API with low latency and high transmission rate. But we are more interested in the security and monitoring features, so let's go into it. Here, you can see the distributions, and we can go into the details. And here are the policies configured, and then security features. This one is Origin Access Identities, also known as OAI. It is utilized to make sure the resources in S3 bucket are correctly used by the authenticated users. And the other one is field level encryption, which uses the key pairs to protect the data in certain field level. So beforehand, we need to settle the public keys, the key pairs. So go into it, you can see the public key must be 2048 bits, which is a non-SA public key. Okay, then it's monitoring. We can view the distribution metrics, and we can see it here. Nothing. That's because we are not doing any options or activities related. If we do that, it will be shown here. Okay, let's go to next. Amazon Chime. This is an application more like for meeting and chatting, just like MS Teams or WhatsApp. So let's go into it and have a look. Here is the dashboard, and here is the manager account. Then we can see the 4 users under this account. We can also invite other users here by typing their email address. Then they will receive an email just like this. If they accept, then this page will be shown. And if they choose use web application, okay, it will be this chat room. We can type some messages here. Then everyone can see it. Amazon Chime also provides the services for the voice connections, so the phone calling is also possible. Next component is Inspector. This application is mainly for the monitoring on EC2 instances, manually or weekly, and it can generate corresponding reports. Okay, in this dashboard, it says we have 9 recent findings and 2 assessments completed. So we go to the findings. Then we can see these items. The severity of all the items are low or informational, which means the security is good. And then we can go to the assessment which are completed and download the report. If we download it, it will be shown like this. And it's the same for the other one. So all the items will be shown in this report. And that's Inspector. Then let's go to the next one. AWS Trusted Advisor. This application aims to the enhancement of the whole system by enhancing the cost optimization, performance, security, fault tolerance, and service limits. So let's go into it. Here you can see that's the dashboard, and the refresh or checks button is gray, which means all the information is the newest. And if we go into the action recommended, we'll find MFA on root account is not configured correctly. That's because we are sharing one common account, so we can do the configurations more conveniently. Of course, in the real world, we need to settle it to enhance the level of security. We can also download all the checks in this way. And here I have already downloaded, so do it again. Then we can see the corresponding report. That's the Trusted Advisor. Last but not least, IAM. This is more like an administrator application. So let's go into it. You can see it on dashboard. We have 5 user groups, 4 users, and 9 roles, but no policies. if we go to the details, you can find 5 different groups. And the first one is for the common policies for all of us. The rest 4 ones are for the certain functionalities of different positions. For example, we go into cons, and he has 9 different policies. But if we go into another one, rules, then he has only 3 different policies. And similar things happen to the other 2 ones. And for roles, we also settle several roles to provide certain services. Because we have already configured the needed policies in these 3 ways, so we did not configure any single policies individually. That's IAM. IAM also has its own analyzer here, so we can follow the introduction. It says it's completely a free service with almost no configurations, so there's no reason not to use it. And we just need to create IAM analyzer account, and archive roles are optional. So let's have a look. Here, analyzers, we go into it, here are the details. And the rules here, that's the example. We settle public access is false, and resource type is like this. So that's all of the introduction of security components. So in conclusion, we have introduced availability zones, VPCs, and subnets, backups and disaster recovery, AWS authentication control and monitoring, and of course security components. I hope you can enjoy this video and everyone have introduced their own parts detailedly and clearly. Thank you for watching.